Good afternoon, students. Today we are going to discuss about fuzzy inference systems. In this fuzzy inference systems, our main outline revolves about the architecture of the fuzzy inference systems. As we know about fuzzy systems, we can see that there is a particular block diagram where there are three important building blocks, namely Fuzzifier, Inference Engine and Diversifier. You can see also one additional block which is called Fuzzy Knowledge Base. Remember, we have already covered the fuzzy rules, membership functions, fuzzy operators. So basically, all those membership functions, fuzzy operators, fuzzy propositions are stored in the fuzzy knowledge base. And by the time when this fuzzifier or inference engine or defuzzifier requires some kind of operators, some kind of membership functions, then all those parameters are extracted from this fuzzy knowledge base, and those parameters are fed to each of the building blocks which basically needs most. You can also see that there is one input side and an output side. Now the question is, what kind of input and output variables are there in case of fuzzy systems? If we are going to, research on this, then it is better if we look at one fuzzy control systems. Now, what about fuzzy control system? Fuzzy control system means if we are going to apply the fuzzy logic or fuzzy inference system in any control system loop, like in temperature control system, like in flow control system, like in pressure control systems. So basically, whenever we are talking about control system loop, we are pretty aware that in day-to-day life, we are dealing with a closed loop system. And a closed loop system requires some kind of, output side and one feedback path where this feedback path is straight away go to input side from its output side, and this feedback path helps to measure any change in output side. That means if I have one desired output variables, desired output values, so if there is any change in output side due to the disturbance occurred in the input side, automatically this fuzzy control system can measure that difference between the desired and the measured value and term it as an error, whether be it positive, whether be it negative, and this particular error or this particular difference is fed back to the input side so that this fuzzy control system automatically tune some parameters of fuzzy sets, which is basically the membership functions, which is basically the fuzzy rules, which is basically the fuzzy operators. So tuning all those fuzzy parameters, this plant will deliver the desired output. So this is how the fuzzy control system works. If we are talking about the first building block, that is the fuzzifier, then what is the function of fuzzifier? So fuzzifier basically receives one crisp input, and this crisp input is basically converted into some linguistic variable using the membership functions, and we know that the membership functions is stored in the fuzzy knowledge base. So what does this mean by this linguistic variable? See, what we have covered till now, when we have already learned the fuzzy rules, fuzzy propositions, fuzzy operators, then we know that any kind of crisp input, like say that is temperature, then we can display, or we can explain, we can outline that particular crisp input or crisp value or crisp parameter by a linguistic variable like x, like y, like z. So basically, if I say that the crisp input is a temperature value, say 10.8 or something like temperature value, so this temperature value can be, explained or can be named by a linguistic variable like x. The second building block is the inference engine. And now this inference engine is basically, having the fuzzy input, right? Fuzzy input. Now this fuzzy input is mapped into again a fuzzy output by some rules. So basically, inference engine works on fuzzy rules. So basically, whenever you have some kind of if-then type fuzzy rules, the rules which we have already, discussed in the fuzzy rules chapter, that we know that we have some kind of antecedent parts, we have some kind of consequent parts. We have one or more antecedent parts, which is the if part, and we have one definite consequent part, which is a then part. So all those if-then type fuzzy rules are basically stored in the inference engine. And inference engine works on that particular fuzzy rules. Now this inference engine can have R number of rules. Any one rule or any two rules or a combination of R number of rules. So here you can see that it will get either a crisp or a fuzzy input. Crisp means there is no fuzzifier building block, and if there is a fuzzifier building block, so automatically inference engine will get fuzzy input, and automatically it will work on these R rules. And you can see that maybe rule number 1 is saying that if x is a1, that means this is the antecedent part, the first block, that results the consequent part as well. That means y is b1. So automatically this x is one linguistic variable, which is the input variable, and y is the another linguistic variable, which is maybe the output variable. And you can see this a1 are the kind of, membership values, which is the fuzzy values, membership values, which belongs to some fuzzy set A, and b1 is another kind of membership values which belongs to fuzzy set B. Similarly, there is rule 2, x is a2. If x is a2, then y is b2. There is also rule R, likewise. If x is AR, then y is BR. So automatically what we get is we are getting R number of fuzzy outputs. But we require only one output, right? Because we have only one crisp input. So we need to obtain one fuzzy output which is analogous to that crisp or that fuzzy input. For this reason, we need one aggregator where all these fuzzy outputs are aggregated to convert it into a single fuzzy output. So this is how the inference engine works. The third building block is called defuzzifier, right? Defuzzifier, the third building block. So defuzzifier, the work is defuzzifier lies in conversion of the fuzzy output which we basically obtain from the fuzzy inference engine to a crisp value using the same membership functions which is related to the ones we used by the fuzzifier. So these are three building blocks, major building blocks, how the fuzzy inference system works. And automatically, whenever this fuzzy inference system works, we know that there is obviously a sense of non-linearity. There is also obviously a sense of non-linearity. Why this non-linearity? Because every crisp inputs and every crisp outputs we are talking about, all those are real-time examples, and we know that in case of real-time examples we are dealing with nonlinear problems. So in nonlinear dynamics we are dealing with nonlinear crisp values, nonlinear fuzzy values, so automatically there should be a mapping of nonlinear mapping from its input space to output space. So that is why if you can see, this is the total nonlinear mapping lies from here to from here. That means from starting to the fuzzy inference engine and automatically the aggregation part and automatically after the diffuser system. So there is the whole nonlinearity lies. Now, based on this nonlinearity fuzzy models, now our next lecture will be on two distinct fuzzy models, very popular fuzzy inference model. One is Mamdani fuzzy models, another is Takagi-Sugeno fuzzy models. And those two models, one by one, we are going to cover in the next class. So this is all for today, and I am giving you the MCQ questions on this, particular slide, which you need to solve out in the Google form, and you need to return back to me by today. So best of luck, students, and you just go through the lectures. If you have any queries, you can ask me any questions regarding this lecture into the WhatsApp group we have made. So that's all for today, and have a good luck. Thank you.